Two blocks are attached to a cable hanging from a fixed pulley system, and we're given the mass of the blocks, and we're asked to find the tension in the cable and the acceleration of the smaller block. And the cable and pulley are assumed massless. So if you just follow the cable which is wrapped around these pulleys, you'll be able to draw the tensile force at certain locations. So the tensile force is uniform in magnitude. So think of this like we're taking the free body of each component of the cable pulley system. So these forces all have magnitude Ft, and therefore the force in this cable is 2Ft, which is the same as the force acting on the block. And if we're taking free bodies of the block, we have the force of weight on block 1 and similarly on block 2. So the force of weight in block 1 is smaller than the tensile force in the cable because the smaller block is expected to accelerate upwards and a larger block accelerates downwards. So in this case we have three unknowns, and I'll leave you to apply Newton's second law on each of these blocks to obtain two equations of motion, and the third equation is obtained from the length of the cable. So we can label this length from the fixed pulley as y1, and the length of these two parts of the cable as y2. So the length of the cable is y1 plus 2y2, and then plus his constant length of the cable that does not change when these blocks move up and down. So if we differentiate this twice with respect to time, the length of the entire cable is constant, and we obtain the acceleration of block 1 plus 2 times the acceleration of block 2. So therefore, in addition to the equations of motion of the block, we have a third equation to solve for the three unknowns. Two blocks are attached by a cable and pulley system, and we're given the mass of both blocks, and we're asked to calculate the force in the cable and the acceleration of the blocks, and make the following assumptions. So drawing a free body diagram for the blocks, and we expect the heavier block to accelerate downwards. So therefore this block will accelerate up the plane. And applying Newton's second law to the first block, and applying Newton's second law to the green block, and now you can substitute for the force of weight of block 1 and 2, add the equations together to eliminate the tensile force, find the acceleration, and then substitute it into either equation to obtain a tension force in the cable. And post your answer in the comments.